Alright, let's go. Number 7, the grabby aliens model. In 2021, Robin Hanson and his team published a paper that fundamentally changed the mathematics of the Fermi Paradox. For decades, we assumed that if advanced civilizations existed, they would be scattered randomly throughout the universe, like towns across a country. But the grabby aliens model suggests something far more aggressive. It applies statistical modeling to expansionist civilizations, societies that don't just explore, but consume. According to the model, a civilization that survives its early technological adolescence doesn't stay small, it expands, and it expands fast, potentially at a significant fraction of the speed of light. These civilizations seize matter, energy, and volume, restructuring entire galaxies to suit their needs. They grow outward in vast spheres until they collide with others, filling the cosmos like bubbles in rising bread. If they were common right now, we would see them. We would see galaxies going dark, we would detect waste heat, but we see nothing. The universe looks pristine. The conclusion is simple: we are early, and somewhere beyond the horizon, the expansion may already be on its way. Number 6, the estivation hypothesis. This scenario comes from a paper titled "That Is Not Dead Which Can Eternal Lie," published by Sandberg, Armstrong and Sovich. It addresses a fundamental inefficiency in the universe. It is too hot. If you are a civilization that has transcended biology and uploaded your consciousness into machines, your primary resource is not land or food, it is computation, processing power, and the enemy of computation is heat. Thermodynamics dictates that computing is more efficient at lower temperatures. The colder the environment, the more operations you can perform for the same amount of energy. Right now, the universe is filled with hot stars, cosmic background radiation, and thermal noise. It is generally speaking a terrible place to run a high-level simulation. In the deep cold future, trillions of years from now, a single joule of energy will be worth vastly more in terms of computation than it is today. To remain active now would be a waste. So the estivation hypothesis suggests they are not dead, they are waiting, slowed down, powered off. But here's the unsettling implication: we are the noise, the energetic biological creatures thriving in the heat wave of the early universe. And if we begin to expand, to radiate heat, to rearrange matter on a galactic scale, we may be degrading the future resources of something far older and far more patient. The silence of the universe is not empty, it is the silence of a library, and we are the only ones shouting. Number 5, the Great Filter, the late scenario. The Great Filter is the single most famous answer to the Fermi Paradox. It proposes that there is a barrier, a statistical improbability that prevents dead matter from becoming a spacefaring civilization. For years, humanity has hoped that the filter is behind us. Maybe the hard step was the origin of life. Maybe it was the leap from single-cell to multicellular organisms. If the filter is behind us, we are the lucky ones. But statistically, that hope is fading. We are finding water on Mars, organic compounds on comets. The building blocks of life appear common. Life may be easy, intelligence may even be advantageous. That points to the uncomfortable alternative. The filter is ahead of us. Civilizations rise, they build cities, they split the atom, they invent radio, they launch rockets, and then, without exception, they disappear. The silence of the universe may not be emptiness, it may be aftermath. Number 4, the shadow biosphere. When we search for life, we look for what we know: carbon-based chemistry, liquid water, DNA. We scan the Goldilocks zones of distant stars and assume that life must follow the same biochemical pathway that happened to occur on Earth. But scientists like Carol Cleland have proposed something far stranger. Life may have emerged more than once on this planet. We could be the descendants of one origin event, and somewhere alongside us, chemically distinct, there could be a second tree of life: microbes without DNA, organisms that use arsenic instead of phosphorus. Life in the deep crust or high atmosphere that remains invisible because our detection methods are built to find us. Now expand that idea to the cosmos. Dark matter makes up most of the universe, normal matter is the minority. If complex structures are possible in that dark sector, then the universe may be crowded, just not with anything we can see. Number 3, the Berserker probe scenario. This is the militarized version of the von Neumann probe concept. A von Neumann probe is simple. It travels to a star system, mines raw materials, builds copies of itself, and sends them on. Exponential growth means that a single probe could spread across the entire galaxy in a few million years, a blink in cosmic time. If we do not see these friendly machines, there are two possibilities: either no one builds them, or someone built a different kind. The Berserker scenario, named after the novels by Fred Saberhagen, suggests the first civilization to achieve interstellar travel may have an incentive to ensure no one else does. They build self-replicating probes with a simple directive: detect intelligent life, extinguish it, reset. The galaxy stays quiet not because it is empty, but because anything that speaks too loudly does not speak for long. Number 2, the simulation termination. This is the ultimate existential scenario. It begins with the simulation argument popularized by Nick Bostrom. The logic rests on three premises. First, civilizations capable of running ancestor simulations are possible. Second, such civilizations would run many of them, billions. Third, if that is true, then simulated minds would vastly outnumber biological ones. Statistically, if you are a conscious being, it becomes overwhelmingly likely that you are inside a simulation rather than base reality. But here is the twist: every simulation has a purpose, it studies something, it measures something, it ends. If we are inside one, we are consuming resources, processing power, memory. As we expand, build supercomputers, and attempt simulations of our own, the load increases. The universe may not be infinite, it may be allocated, and when the experiment reaches its conclusion, there is no apocalypse, no warning, just termination. Number 1, the cosmic zoo hypothesis. And there is one more possibility, the cosmic zoo hypothesis. It suggests the silence is intentional, not because civilizations are gone, not because they are waiting, not because they were eliminated, but because they are watching. In this scenario, advanced societies deliberately avoid contact. They enforce a kind of galactic quarantine. Earth is not unimportant, it is protected, or contained. Just as we observe animals in a wildlife reserve without interfering, they may observe us without revealing themselves. Radio silence becomes policy, intervention becomes taboo. This would explain the absence of signals, the lack of megastructures, the quiet sky, not emptiness, restraint. But there is an implication: zoos have fences, and subjects are not consulted. If we are being observed, we are not participants in a cosmic conversation, we are part of a study. If these ideas intrigue you, explore further, like the video, subscribe, and let's keep asking the quiet questions the universe refuses to answer.